All right, let's dive into Magma, a foundation model for multimodal AI agents, a paper that's really pushing the boundaries of what AI can do.
Yeah, it's pretty amazing.
Forget just understanding text and images. Magma can actually plan and execute actions in both the digital and physical world.
It can.
For those of you who are busy, here's the summary.
Well, Magma is trained on this massive data set of images, videos, and robotics data. Think of it kind of like learning by watching YouTube tutorials and then actually following along.
Oh, wow.
It means Magma can do some really cool things, like navigating a website based on your instructions, or even control a robot arm to manipulate objects in the real world. It's a huge step towards truly intelligent AI agents that can, interact with their environment in a way we haven't really seen before.
Yeah, that's what's so fascinating about this. Now, let's unpack the details a little bit.
Okay.
One of the things that really stood out to me was Magma's ability to interpret information from all these different sources.
Right.
It's not just about recognizing objects, but understanding how they relate to each other, even in videos.
Yeah, it's what they call multimodal understanding in the paper.
Okay.
It goes beyond just recognizing a cat in a picture. Magma can understand the spatial relationships between objects, like a cat sitting on a table. Even more impressive is that it can understand the actions happening in a video, like a cat jumping off that table.
That was the part that really blew my mind. I mean, they had this great example in the paper where they showed Magma a picture of man ironing clothes on top of a taxi.
Oh, yeah.
Immediately, Magma was like, hold on, this is unusual.
Right, it noticed that.
It wasn't just describing what it saw, it was understanding the context and flagging what was out of place.
Exactly. It's one thing to be able to label objects, but another to understand how they relate to each other in the overall scene, you know? This level of understanding is crucial for an AI agent that needs to interact with the world. Imagine a robot trying to navigate a room. It needs to understand not just that there's a chair there, but that it can't walk through the chair.
Right. So we've established Magma can understand the world in a pretty sophisticated way.
Yeah.
But what I found mind-blowing was its ability to actually act on that understanding. That's where these really innovative training techniques come in.
Yeah, the set of mark and the trace of mark?
Yes. The SoM and ToM?
Yes.
Can you explain those a little bit?
Essentially, they allow Magma to connect language commands to specific actions in the visual world. Think about something like booking a hotel on a website. Instead of just understanding the concept of booking a hotel, Magma can actually understand how to interact with the website to make that happen. So the SoM allows Magma to identify those actionable objects within an image, like, buttons to click or fields to fill out. It's like giving the AI a map of the interface and highlighting the areas it can interact with. And then the ToM takes that a step further.
So it kind of allows Magma to understand actions over time.
Right.
Like in a video, it can predict how objects will move and how those movements relate to actions.
Exactly. For example, if Magma sees a video of someone clicking a button on a website, it can learn to predict where that cursor will move and what the effect of that click will be.
Wow.
It's like watching a master chess player, thinking several moves ahead.
That's a great analogy.
Yeah, it really can. And that ability to predict and plan those actions is what really sets Magma apart. It's not just reacting to what it sees.
Yeah.
It's like anticipating what's going to happen next and planning its actions accordingly.
I see. But I'm curious about how all this actually translates into real-world applications.
Right.
The paper talks about Magma being used for UI navigation and also robotic manipulation. Can you give me some specific examples?
Absolutely. Let's start with that UI navigation. Imagine you're trying to book a flight on a website.
Okay.
You could give Magma this natural language instruction like book a flight from San Francisco to New York on July 15th.
Okay.
And Magma could actually understand that instruction and then interact with the website to actually find the right flight and book it.
No way.
Yeah. It would use its understanding of the website's layout combined with its knowledge of how to interact with all the different UI elements to complete the task.
So no more spending hours clicking through drop-down menus and filling out forms.
Yeah.
Just tell Magma what you want and it handles it.
Exactly.
Wow, that's amazing.
And it's not limited to just booking flights. They showed that Magma could handle a variety of UI navigation tasks, like installing an app, ordering food, even playing a game.
That's really cool. Okay, so that's the digital world. What about the physical world? How is Magma being used for robotic manipulation?
So this is where things get really exciting. They trained Magma on this massive data set of robotics data from the OpenX embodiment project. This data includes these real-world demonstrations of robots performing all sorts of tasks, like picking up objects, opening drawers, even cooking.
So Magma is learning from watching robots in action, just like it learns from watching human in those instructional videos.
Exactly. By observing these real-world demonstrations, Magma learns to associate language commands with those specific robot movements.
Oh, I see.
For example, if you tell Magma to pick up the blue block.
Okay.
It can translate that command into this sequence of actions that the robot arm can execute to actually pick up the block.
Wow, so we're talking about robots that can understand and respond to natural language instructions.
Yes.
It's like something straight out of a sci-fi movie.
It really is. And they tested Magma's robotic manipulation abilities on like a whole bunch of tasks, like pushing a chip bag, peeling a potato, closing a drawer, and even picking up a delicate mushroom.
Wow.
The results were remarkable.
All those tasks require a lot of precision with dexterity.
Yeah.
It's not easy for a robot to do those things, you know?
Right, right. And what's especially impressive is that Magma was able to achieve this level of performance with relatively little training data compared to like some other AI models. That speaks to the efficiency of its training techniques.
Yeah, absolutely. This actually brings up an interesting point, though. We've talked a lot about Magma's performance on these very specific tasks, but how adaptable is it? Can it like easily be applied to new domains or tasks that it wasn't specifically trained for?
That's a great question, and it's definitely something the researchers addressed in the paper.
Okay.
They believe that Magma's foundation model approach makes it very adaptable.
Okay. Can you elaborate on that a bit? Like, what makes a foundation model more adaptable than other types of AI models?
Well, traditional AI models are often trained for a very specific task.
Yeah.
For example, you might have one model that's like really good at recognizing cats in images, and another one that's good at translating English to French.
Okay.
But those models can't do anything else.
So they're kind of like specialized tools designed for a very specific job.
Exactly. A foundation model, on the other hand, is trained on a much broader data set encompassing, a wide range of tasks and domains. This gives it a more general understanding of the world.
Oh, okay.
Which allows it to be adapted to new tasks more easily.
So it's like a Swiss Army knife of AI.
Yeah.
You can use it for a variety of different tasks just by changing the attachment.
That's a great analogy. And in the case of Magma, you change the attachment through this process called fine-tuning.
Can you explain how that works?
Yeah, imagine that you want to use Magma to control a robot arm that sorts packages in a warehouse. You would take the pre-trained Magma model,
Right.
and then fine-tune it on a data set specific to that task. This data set might include images of different types of packages labeled with their corresponding destinations.
Okay.
It might also include videos of humans demonstrating how to sort those packages.
Oh, so you're essentially giving Magma this crash course in package sorting building on its existing knowledge of the world and its ability to control the robot arm.
Precisely. And the really remarkable thing is that this fine-tuning process can be quite efficient. In some cases, they were able to achieve really impressive results with just a few hours of additional training.
That's wild. It means that you don't need to start from scratch every time you want to apply Magma to a new task.
Right.
You can leverage its existing knowledge and abilities and then just fine-tune it for that specific application.
Exactly. And this adaptability is one of the things that makes Magma so exciting. It has the potential to revolutionize a wide range of industries, from manufacturing and logistics to healthcare and education.
Okay, let's talk about some of those potential applications in a little more detail. The paper only scratches the surface,
Right.
but it hints at some pretty exciting possibilities. Where do you see Magma having the biggest impact in the near future?
Oh, there are so many. One area that comes to mind is personalized robotics.
Oh, interesting.
Imagine having a robot at home that can actually learn to do tasks that are like specific to your need and preferences.
Okay.
It could learn to tidy up your workspace or prepare your favorite coffee or even, assist you with some physical therapy exercises.
That would be incredible. It's like having a personal assistant, but like one that can actually perform these physical tasks in the real world.
Exactly. And because Magma can adapt to different environments and learn these new tasks so quickly, these robots could actually become integrated into our daily lives.
Yeah.
They wouldn't be limited to just these pre-programmed routines. They could learn and evolve as our needs change,
It really changes what's possible, right? Beyond personalized robotics, I'm also really intrigued by the potential applications in healthcare.
Uh-huh.
We've already talked about robots assisting in surgery.
Yeah.
But I imagine Magma could also be used to develop intelligent prosthetics that respond to a user's intentions.
That's a fascinating application. Imagine a prosthetic limb that can learn to anticipate the user's movements
Yeah.
and respond accordingly.
Oh, wow.
It could provide a level of dexterity and control that we haven't seen before.
We're talking about a future where people with disabilities could regain lost abilities and live more fulfilling lives.
Absolutely. And it's not even just about, restoring lost abilities. It's about augmenting human capabilities.
Right.
Magma could be used to develop things like exoskeletons that enhance strength and endurance, allowing workers to perform those really demanding tasks more easily and safely.
Yeah, the possibilities are truly endless. Okay, but I know that you are also super interested in the technical details here.
Always.
Can you give us a little peek under the hood and explain how Magma actually works at like a deeper level?
Sure, let's get into the architecture.
Okay.
At its core, Magma utilizes a transformer-based architecture.
Okay.
These have become the go-to for like complex language processing and are increasingly being used for these multimodal tasks.
So how does a transformer help Magma process information from all these different sources?
Like images and text and things like that.
Yeah.
Well, transformers are really good at handling sequential data.
Okay.
Whether it's words in a sentence or frames in a video,
Agreed.
they can analyze that entire sequence simultaneously, which allows them to capture these really complex relationships and dependencies that might be missed by more traditional models.
Okay, so the transformer is like a brain of the operation here.
Right.
But how does Magma handle visual input?
So that's where the vision encoder comes into play.
Okay.
In Magma, they use this really powerful convolutional neural network called ConvNeXt. It's designed to extract this really rich set of features from images and videos.
Oh, so instead of just identifying objects, it's like analyzing the image at a much deeper level.
Exactly. ConvNeXt captures spatial relationships, textures, colors, all those subtle details that give an image meaning.
I see.
It basically translates that visual world into a format that the transformer can understand.
So the vision encoder acts like Magma's eyes,
Yes.
feeding information to the transformer, which then processes everything together.
Exactly. And remember those techniques we talked about earlier, the SoM and the ToM?
Yes.
Well, they play a really important role here as well.
Yeah, because they help Magma focus its attention on the actionable elements within the visual input, right?
Precisely. The SoM highlights those objects that can be interacted with, while the ToM predicts how those objects might move over time.
Okay.
This allows Magma to plan its actions super effectively.
Wow. So it's like Magma is constantly thinking several steps ahead, just like a skilled human would when performing like a complex task.
Exactly, and by combining all these elements, that transformer, the vision encoder, and then the SoM and ToM Magma can not only understand the world around it, but also act on it intelligently.
That's really remarkable.
It's a remarkable achievement in AI research.
Before we wrap up, is there anything else you'd like to highlight about Magma or its potential impact on the future of AI?
I think the key takeaway here is that Magma represents this paradigm shift in how we think about AI development.
Okay.
It's not just about building models that can perform specific tasks,
Right.
It's about building models that can learn and adapt to new situations just like humans do.
It's about building AI agents that can truly understand and interact with the world around them.
That's right. And while Magma is still in its early stages of development, it really does provide a glimpse into what's possible. It's an exciting time to be working in this field.
It really is. Well, that brings us to the end of our deep dive into Magma. Thanks for joining us today, and be sure to check out the full paper if you want to explore this fascinating research in more detail. We'll see you next time for another exciting exploration of the cutting edge of AI.